Sorry for the sir internet disruption, sir. I'm resuming this my presentation. Sir, am I audible, sir? Hello.
Yes, you're audible.
Sir, sorry for the inconvenience, sir. Sir, I'm resuming my presentation. So we're discussing where I'm showing the visual symptoms of nutrient deficiencies. The first one is the nitrogen deficiency symptoms. Then the second one is the potassium deficiency, and the last one is phosphorus deficiency. And the final one is the handling with proper nutrition. So the problem statement, as we have already discussed, that the manual inspection or soil testing and traditional methods are time-consuming, subjective, and lack scalability. So the accuracy cannot be determined or may not be the correct one. So another point is that the current AI-driven methods, which we have already seen, in those where they have used the control or limited photographs taken in control or limited field conditions, and therefore they do not support the real-time inference and are not readily deployable in formal day-to-day operations. So there remains a significant gap in developing a robust, interpretable, and field deployable AI solution capable of accurately detecting and classifying NPK deficiencies in rice leaves under diverse environmental conditions. For example, very light background clutter. And the second one is providing real-time actionable feedback to support a timely nutrient intervention. Our system, we want to develop a system which will provide instant solution, instant advice to the farmer whether while they upload their images, what amount of nitrogen, phosphorus, or potassium, or the relevant fertilizers are to be applied by the farmer according to their field condition. So integrating seamlessly with user-friendly mobile or edge platforms for practical use by non-experts in rural and resource-constrained settings. So when to integrate, we are going to develop a mobile application or low resource application so that each and every user, especially the growers or the farmers, will be able to use the facility or the feature with their already existing mobile phones. So therefore, systems for rice nutrition monitoring that is both technically robust and practically usable by the farmers and agriculture stakeholders we have developed. We have conducted a critical review of the existing research. So we have seen various researchers are doing deep learning, developing deep learning models and or CNN models or different technology they have used, and we have find out some key points. For example, the Kolhar et al. They are using deep learning models, ML3 vision transfer exception, and they are getting 95.14% of accuracy. And the second one is using deep learning model exception V3 which is 16. They are getting 75%, and so on. And most of they are using convolution and neural network models, different models, and for some of using also for classification k nearest neighbor algorithm. So we have seen from this most of the deep learning models. So most of the CNN models like DCC16, DCC19, MobileNet, AlexNet, ResNet 50, ResNet 152, GoogleNet, DeskNet, Inception, V3, Exception, etc. are used to predict the health of rice plants. And the study shows that the accuracy of the CNN models ranges from 70% to near about 100%. And machine learning algorithms for predicting nitrogen levels are also used, like random forest, support vector machine, XGBoost. They have shown high accuracy rates in predicting time nitrogen status and establish the robustness of systems. And in the review, we have seen that different researchers are able to predict the nitrogen status of rice plants and the yield by examining different vegetation images through the multispectral CIR RGB images collected with the help of UAV drone cameras or high resolution cameras or CIR cameras. So the review work we have performed, we have presented the review work in international conference on innovation and challenges in competing and innovative technologies for sustainable future (ICCIT), organized by British University of Vietnam. This is the participation certificate, and also the paper published in a book published by IJ Global, a critical review on rice nutrition monitoring using AI-based technique. We have published a chapter in the uh, book, Innovations and Challenges in Competing Games and Data Science. Then from the studies, we have found some research gaps. So we are showing the research gaps. The first one is a limited focus on real-time monitoring. So most of the models are designed for actually expert or some scientific study or for some experiments. The systems are not developed for providing real-time solutions to the farmers or the growers. Actually, they need the solution is required by the farmers or in the root level. Actually, they are growing the plants, so they need the facility. But most of the models are designed for the experts or the data scientists, who will do some research and find out some another solution. But our goal is to provide a real-time solution to the farmers, the farming community. And the second is disparity in dataset quality and size. Some studies have small data and varying image quality, which hinder the model performance. So more extensive and diverse datasets we're planning to develop through our research. Then the third one is a challenge in real world conditions. So the image in which we got into practical field contains different types of noise. So most of the model is not treating the noise before processing the image. So we are focusing on that point also. We are going to first take the input from the user and first pre-processed with the help of different denoising techniques or different image enhancement techniques. Then we'll go for further processing. Then the next is the fourth. It's a comparison of different deep learning frameworks. So several previous work compare different DL frameworks till date. However, more comprehensive evaluation of the framework against a variety of models with their pros and cons, especially for agriculture domain, is required. So we are we'll be working on that gap also. And the fifth one is integration with precision agriculture. So research has to be done on integrating nutrient efficiency detection system with precision agriculture practice like variable rate fertilization to use fertilizer as optimal and service wastage, because most of the we have seen more of the scenario the farmers are using the fertilizer in blanket dose for all the crops. They are spraying same amount of fertilizer in each case, but whether it is required or not required, it is not determined first. So precision agriculture, the variable rate fertilization. So which crop needs fertilization, only that crops will be fertilized. So that concept is we are focusing on here also. And the final one is the development of user-friendly tool. So, I already discussed that most of the tools are designed for the experts or the scientists, but we are going to develop user-friendly tools which will help the farming community. So, with the help of which they will be able to monitor their crop health in the field instantly. So, these are the research gaps of our and the objectives are to perform a comparative study of image denoising and enhancement techniques suitable for pre-processing rice images captured under field conditions. So, as we have already discussed that, where first do pre-processing, we'll emphasize on pre-processing the images. So for pre-processing, we'll use two techniques. One is the image denoising technique, and another is the enhancement technique. So through image denoising techniques, we will remove most of the noise available commonly, and then we'll enhance the image to extract the details from the images. So the second one is the design and development of an adaptive processing and enhancement pipeline that improves image quality for nutrient deficiency detection in real-time scenario. So we'll first compare the techniques. Then in second step, we will design our own image processing technique, which will help in further processing. And the next one is to evaluate and fine-tune and deep learning models. So we'll already develop models. We test the models, and we check whether they will be able to accurately classify or predict the rice nutrition levels. For instance, I mean, we will take nitrogen, phosphorus, potassium. So for these three components, we will check the models. Then finally, we develop a lightweight and user-accessible prototype system for real-time rice nutrient monitoring and fertilizer recommendation using AI models. So for all the use, we will use computer vision, and we have conducted a few of our research work. So first, we have already successfully completed the critical review on nutrition monitoring using AI-based technique, and published the findings in a review paper, which I already mentioned. The second, we have conducted comparative study of different image denoising techniques, techniques for pre-processing digital images of rice leaves. So it is the first part of the objective one, and we have used the images available in Kaggle rice leaf images, and the noise simulated in our study are Gaussian, salt paper, speckle, and random. And we have used image filters, mean, Gaussian, median, bilateral, and BM3D filters. And key findings of the study is the bilateral filter is most effective in denoising an image with Gaussian noise, and median filter is most effective in denoising an image with salt paper noise, and Gaussian filter is most effective in denoising an image with speckle noise, followed by BM3D filter. But we have seen that BM3D filter removes some of the important details, which is actually essential for the processing, is removed by the BM3D filter. So we actually not recommend BM3D. We have also another reason for not recommending BM3D filter for our study. I will discuss in next part. Then bilateral filter is outperforming in denoising random noise. We have also studied the time required by all the filters. So we have seen that the linear filters like Gaussian and mean are taking very less amount of time. For example, it takes around 0.3 to 0.5 second for denoising 500 images. And median filter is also performing well as the linear filters. Also, median filter is taking around 5 to 7, sorry, 0.5 to 0.7 second for denoising 500 images. And bilateral filter, we have seen that the result is good for bilateral filter, but it is taking around 8 to 11 seconds for denoising 500 number of images. And BM 3D is the slowest one, because it is taking more than 200 seconds for to perform the same task for denoising 500 images of 500 by 230 pixels. So these are the findings of the study, key findings, and this work is presented in second international conference of data-driven AI organized by the Assam Kaziranga University, Jorhat, and I received the best paper award. And the abstract was also published in data-driven AI, and the paper prepared on the findings was submitted to a paper, and it is it has passed the first review process in Officer Journal. And third, we have performed a complete study of image denoising and enhancement technique. So it is the second part of the first objective, where we are combining image denoising techniques and enhancement techniques. For image denoising techniques, we have already discussed the commonly available image denoising techniques. The linear filters and non-linear filters are used. And for enhancement technique, here we have used the contrast limited adaptive histogram equalization techniques, CLEHE. So with different parameters, we are using different parameters to the CLEHE and combining it with different denoising techniques. And here also we have already completed a paper or with the findings, and it is already accepted in the accepted for publication in a Web of Science journal, IJANS, International Journal of Agriculture and Natural Science. Then we are actually I'm from agriculture background, means working in a agriculture university, and I'm working for Jorhat and Madhuri district. So actually our jurisdiction, our office jurisdiction is Jorhat and Madhuri district. So therefore I am choosing the farmer field with the rice crops under the supervision of Krishi Vigyan Kendra Jorhat, from belonging to Jorhat and Madhuri district. So then the materials and the methods, methodology. So materials required for our study are the smartphone cameras or UAV mounted RGB sensor for air service. Then computer infrastructure we need with GPU accelerated workstation. Especially we're mentioning this, and for large scale model training we will use Google Colab. Then software libraries, Python 3.1 on or higher we will use. Then the libraries OpenCV, scikit-image for image processing, NumPy and Pandas for data manipulation, and TensorFlow or PyTorch for deep learning models. And maybe more libraries will be used in further study. So next is methodology. So first, the data is the main thing. So first we'll. Sir, am I audible? Okay, sir. Hello? Hello, sir? Hello, sir?
Yes, sir. You are audible.
First is the data acquisition. So for we'll the used nutrient deficiency image data sets of rice slips available in public repository like Kaggle. And second, we captured leaf images at different processes under diverse lighting and background from farmer's field. Then image pre-processing and augmentation. So we denoise with image filtering techniques to remove common noise, then enhance contrast using histogram equalization techniques, then simulate additional noise and apply geometric transformations like rotation or flip to expand the data set. So this is image processing and augmentation. Then we'll go for leaf feature extraction and model training. Then we'll go for validation, and finally we'll deploy a prototype for farmers. So from this research, we are expecting these outcomes. So first one is a rice nutrient efficiency image dataset with more than 500 images of rice leaves. The second, near real-time NPK recommendation, enabling optimized fertilizer use and improved use and productivity. So till now, the study or for this review literature and for the works we have conducted, we have used those literatures, references I am showing here. So thank you, sir. So this is my presentation, and I'll know you suggestion regarding my and questions regarding my presentation, please, sir.
So dear members, Rupjyoti just presented the work or the proposed title for his PhD. 1 year already completed, and he has also already done some works that's being presented in conference and also accepted in the in some journals. And now, as this is the synopsis presentation, so we need your suggestion, if right. And also, if you think that the objectives were also slight modifications required, then you can let us know, or if everything is okay, then we can go ahead with this. Thank you. So, sir, if everything okay, then you can
Hello,
just.
sir. May I add something over here?
Sir? Pardon, sir?
Hello.
Hello, sir.
Yeah, I have some observation. Can I say something?
Sure,
Ye-
sir.
Am I audible?
Yes, sir. Yes, sir.
Hello.
Yes, sir. You are audible, sir.
Okay, okay, okay. So my first observation is that you are going to take only nitrogen, phosphorus, and potassium for this nutrient
Yes, sir. Yes.
as a parameter. So is it not related some kind of other parameter also, some kind of other nutrient like zinc, sulfur, magnesium,
Yes, sir.
calcium,
Yes.
something like that?
Yes, sir. But the major components, the major fertilizer required, or the major nutrient required by the crop for actually till and into the production stage. So they need the compulsory nutrients are the nitrogen, phosphorus, and right.
Yes, now it is visible. Okay. Okay, you can resume.
Uh, Yes, sir. Actually, the major nutrients, the macronutrients are nitrogen, phosphorus, and potassium. Actually, which are mandatory for plant growing. So we are focusing on these. Actually, a total number of total 16 nutrients are required by rice plants. So, but we are focusing on the major nutrients only. Actually, sir. And another thing, sir, actually, especially the nitrogen, phosphorus, and potassium shows actually visual symptom deficiency shows actually visual symptoms. Other sometimes actually they are not.
Yeah, we
So,
are very sorry for the network disruptions. So he was saying that these three this
sir, am I audible, sir? Hello, sir.
Yeah. Now you're audible. Huh?
Yes, sir. Actually, sir, first thing is that actually nitrogen, phosphorus, and potassium are the major nutrients required by a plant to grow. Actually, so another one is that in the nitrogen, phosphorus, and potassium deficiency, they show some visual symptoms, but in deficiency of other nutrients, actually not showing any, but not shows and doesn't show any symptom visual symptoms which we can handle actually. So therefore, we are taking nitrogen, phosphorus, and potassium only, sir.
Okay, finally, you are going to classify y- because your problem is related to classification, right?
Yes,
By
sir. Yes,
using the deep learning models,
yes, sir.
is not it?
Yes, sir. Yes, sir.
So how many classes you are going to consider finally, like nutrient related or soil related? So
Sir,
that
now,
thing is not clear from your objectives basically, because you have mentioned simply that you are going to develop some evaluate and deploy, something like that. You have used some term, and
uh,
you have given more emphasis on the image denoising or say image enhancement kind of things.
uh,
uh,
uh, yes, sir. Actually, sir, those are proposing steps, but the main focus is to develop our model which will handle or which will detect the deficiency of nitrogen, phosphorus, and potassium, and they will
so basically you are going to collect the data related with say nitrogen related. If something will happen to a plant leaf, you are going to collect the images.
yes, yes, sir. So actually,
Similarly,
the
so like that you are going to create the images or what?
sir, pardon?
No, I mean to say, as you are going to three parameters
Yes.
like nitrogen, phosphorus, potassium.
Mm-hmm.
So accordingly, you are going to collect the images related to say if some plant like rice plant leaves are have some deficiency related with nitrogen, you are going to collect the image.
Yes, actually for creating data sets, we will collect the data for four classes. One for the healthy plant leaves, healthy rice leaves. Then the second for the nitrogen deficient rice leaves. Then phosphorus
Okay,
deficient
okay,
rice
okay,
leaves
okay.
and potassium deficiency rice leaves actually. So they
So
will,
basically, you are going to have four different classes.
yes, yes, yes,
And just I'm not in from that particular domain, but my just one kind of query is that depending on the, because we are having various kind of rice, right?
yes.
Rice plants. So are you going to consider some kind of rice only, or say it will be a generalized model?
Sir, it will be a generalized model, but only some specific rice varieties are there where their leaf colors are different. They will not be covered in this model, not covered by the model, but all the more than 90% of the varieties will be covered because they bear the same same color actually, their leaves actually.
Mm-hmm. No, as you are going to pick up Jorhat and Majuli district, so in that region, what kind of rice cultivation is happening? So at least you could have give some kind of enlightenment to us, like these types of varieties are available. So
Uh,
in these varieties, these types of problems are associated.
Sir, actually, the varieties available in used in Assam are actually not like that. They do not have different types of behavior in case of their leaf color. We'll actually leaf color. We'll treat. We'll actually analyze the leaf color or leaf their structure, or we'll actually work on those and especially Assam or Jorhat or Majuli does have actually different kind of rice. We uh, use Jorhat and Majuli as a study area because I'm working in this area actually. But otherwise, there is no difference in the rice grow in the leaf color. The rice grown in here or in suppose on Vietnam or in other countries or other states, so they have the same properties actually. So therefore the model will work for all kind of rice varieties. So as I have mentioned, for only few the very few number of varieties, have some different leaf color will not be covered by the model, but most of the varieties will be covered by our model actually.
Ha, ha, ha. Yeah, I mean to say like that kind of information you must have to be included in your synopsis, like because otherwise it seems to be like a very generalized kind of works.
Yes, yes.
We'll add that part.
Yes, sir.
Okay.
Yes, sir. We will add this, sir.
Mm-hmm.
Yes, sir.
Ah.
Sir, sir, any more, sir?
Any others?
Like in your objectives, I think objective number 1 and 2 you can merge it, because in one objective you have mentioned like you are going to review image preprocessing. Then second one you have said like you are going to propose or something like that. So I think 1 and 2 can be merged because they are having the same properties. Uh, and regarding the development of a deep learning models, there you can give more emphasis.
Yes.
Sure, we'll do that.
Yes, sir. Yes, sir.
Hmm. So whether you are going to propose only one model for all these things, or you are going to propose different kind. So that kind of pipeline you should maintain, I think. So that is my suggestion.
Yes, yes. Thanks.
Mhm. Okay, fine from my end.
Okay, thank you, sir.
So thank you, Rahul sir. That's those are the good suggestions, and obviously we'll maintain that part. Means we'll keep one part that what type of rises we are going to cover. Basically, as the color is concerned, so we'll mention that part. And as you suggested, the two objectives we are the same thing, so we'll merge them, of course. And we are going to work for one particular framework we are going to develop. So that is mentioned in the fourth objective. So that is okay. And thank you very much. And other members, if any suggestion, with us, Dr. Hobesh sir also. He is from Agriculture University, senior scientist. So sir will help us, of course, during the work with his specialized knowledge on this topic. And with us, Dr. Puspendra sir, as we have already introduced, but means because of some network disruptions, maybe some part few members missed. So any other suggestion from the other members, or else we'll move forward with this for the title registration. So members, kindly suggest if you have anything that you want to comment.
Okay, good morning, sir. I'm Dr. Bobes. Am I audible, sir?
Yes, sir. Good morning.
Okay, sir. Morning. Actually, I was driving, so I'm in between. I have lost my connection, I think so. Again, I saw
I think network issue is there, but
while let
now we can hear it.
and whatever I have seen this, whatever I've got, that means whatever I've seen in the slides, I think those were very nice, and Rupjyoti have done his homework very nicely and presented very nicely, I must say. And the Bonia sir, he have also said some suggestion. I have had some means query which was somewhat same with that of this Bonia sir. He already made all those suggestions, and I think it will be good. And whatever this help that will be required from my side, and that will be, I'm always ready. And Rupjyoti is there, so he will always used to come to Assam University. So it will be done. So from my side, it is okay, sir. I think so. And you have presented very nicely, and it will be a very good piece of work. I think so. It will be a good, some very relevant information. It will be coming out. So if any queries or any things will be there later on, we can discuss, sir. No problem. But from my side, it is okay, sir. Thank you, sir.
Yeah,
Thank
thank
you.
you very much, sir. So, Puspendra sir, is it okay? Puspendra sir, I think again some problem is there. But as per my conversation with him, because I discussed with him about his problem, and he said that it was okay, and will implement the suggestions from the Rubul sir's, Bhavesh sir, and from the Puspendra sir, as he said already okay. So respected members, with this we are going to conclude the synopsis presentation of Rupjyoti, and we go for the title registration with few changes that suggested by you. And during the process, we may need your signatures. So that can be either physical mode, means we can meet you, or if it's possible, we will go through the online, means if you share the signature at a particular position, we'll fix it up. So once again, thank you very much. So I hope that very soon we'll meet for some new discussions. As I said, that it is a continuous process. We again need your suggestions, and of course some of your insights, because all of you have a good research background. We know personally Rubul sir, Puspendra sir, Bhavesh sir. You are the persons with expert knowledge on this. So time to time we will discuss and we'll move our works. So with this, we are concluding this presentation. Thank you.
Thank you so much, sir.
Thank you, sir. Thank you.
Thank you, sir.